Hello everyone. Today we're going to learn about the product rule. Now before we get into that, we're going to start off with a warm-up so that way we can investigate exactly what the product rule is. So suppose that we have a function h of x which equals to f of x times g of x. And f of x is x squared plus 2x and g of x is 3x minus x to the fourth. We're going to find f prime of x times g prime of x. So let's go ahead and find f prime. F prime of x is going to be 2x plus 2. And g prime of x is going to equal to 3 minus 4x to the third. Now we're going to figure out what is f prime of x times g prime of x. So we're going to multiply what we just got, the 2x plus 2 times the 3 minus 4x to the third. So we're going to have to distribute. When we distribute the 2x, we get 6x minus 8x to the fourth. And then when we distribute the 2, we get plus 6 minus 8x to the third. Remember to always write our answers in standard form. So our final answer for f prime times g prime would be negative 8x to the fourth minus 8x to the third plus 6x plus 6. So now we're going to actually find h prime by multiplying out the factors of f times g and then figuring out the derivative. So h of x is equal to f of x times g of x. So we're going to do x squared plus 2x times 3x minus x to the fourth. We're going to distribute. So this is going to equal to 3x to the third minus x to the sixth. And then when we distribute the 2x, we get plus 6x squared minus 2x to the fifth. Now let's find the derivative. So h prime of x is going to equal to 9x squared minus 6x to the fifth plus 12x minus 10x to the fourth. And in standard form, that would be negative 6x to the fifth minus 10x to the fourth plus 9x squared plus 12x. When we compare what we got for h prime, it does not equal to f prime times g prime. And this is because f prime times g prime is not necessarily the derivative of h of x. This is where we are going to have to apply the product rule. So to answer this question, does h prime equal to f prime times g prime? No. So we cannot do our problems like that. And this is where we'll have to apply the product rule. Now the product rule, if you have h of x which is equal to f times g, then h prime is going to equal to f prime times g plus f times g prime. So to show that this rule works, we're going to apply this rule to h of x that we already found earlier on in our warm-up and see if we get the same answer. So let's try it. So we're going to do h prime of x is equal to, now what we do is we find the derivative of the first factor, so 2x plus 2, and you leave the second one alone and multiply, so 3x minus x to the fourth. Plus, now we leave the first factor alone, and we multiply with the derivative of the second factor, which is 3 minus 4x to the third. We're going to have to multiply all this out to get our final answer. So let's distribute the 2x plus 2, and we would get 6x squared minus 2x to the fifth plus 6x minus 2x to the fourth. Now we're going to distribute these second factors here. So plus 3x squared minus 4x to the fifth. And now we'll distribute the 2x. We get plus 6x minus 8x to the fourth. Combine like terms and write in standard form. We have this negative 2x to the fifth minus 4x to the fifth, which is negative 6x to the fifth. Negative 2x to the fourth minus 8x to the fourth is minus 10x to the fourth. 6x squared plus 3x squared is plus 9x squared. And finally, 6x plus 6x is plus 12x. Now, when we compare this answer to what we found earlier when we distributed, we have negative 6x to the fifth minus 10x to the fourth plus 9x squared plus 12x. And we see that we get the exact same answer here. So the product rule does work. Now, was it necessarily faster in this case? No, it wasn't. Sometimes it is easier to multiply out your factors and then using the power rule than using the product rule. However, there are examples when you have no choice but to use the product rule. And we're going to look at a couple of those now. So, for example, A, we have sine of x times cosine of x. I have no choice here but to use the product rule. So let's go ahead and try this out. We have h prime of x is going to equal to, now we find the derivative of the first. The derivative of sine is cosine x, and leave the second alone. Plus, now we leave the first one alone, and multiply by the derivative of the second, which is negative sine x. We can simplify this a little bit. Cosine times cosine is cosine squared x, and sine times negative sine is a negative sine squared x. And this would be my answer. There's really nothing else you can do from there. If you could simplify, you would, but you can't. Okay, so now we're going to go ahead to B. Now, B is one of those examples where this would actually be easier if you multiply everything out and then use the power rule. But we're just going to go ahead and practice the product rule. So let's try it out. So we have f prime of x would equal to, find the derivative of the first, so 4x plus 3 times the second one we leave alone, so x squared plus x, plus, now we leave the first one alone, 2x squared plus 3x, and multiply by the derivative of the second, which is 2x plus 1. We're going to go ahead and distribute everything. And this would give us 4x to the third plus 4x squared plus 3x squared plus 3x. Now we're going to go ahead and distribute the second factors. So plus 4x to the third plus 2x squared plus 6x squared plus 3x. And now we're going to go ahead and combine like terms. So we have 4x to the third plus 4x to the third is 8x to the third. 4x squared plus 3x squared is 7x squared, plus 2x squared is 9x squared, plus 6x squared is 15x squared. And our final terms, 3x plus 3x, would be plus 6x. Now again, this was a little bit more work. You could have just multiplied everything out at the beginning and then used the power rule, but I just wanted to practice this product rule. Now for C, we have k of x is equal to 3x plus 2 times cosine x. Here we have to use the product rule. So we have k prime of x. We find the derivative first, which is just 3. Leave the second alone, so cosine x. Plus, now we leave the first one alone, 3x plus 2. And we multiply by the derivative of cosine, which is negative sine x. We can now multiply this out and simplify. So 3 cosine x minus 3x sine x minus 2 sine x. Now, sometimes our answers don't necessarily look very pretty, nor do they look very simple, but this would be our derivative. Now, over here, we have g of theta, which is equal to 3 theta plus theta times sine theta. Now, this is plus, so you don't necessarily have to use a product rule for the whole thing, but theta times sine theta, this is a product. So here, we're going to have to use the product rule. So when we're finding the derivative of g of theta, this would equal to 3 plus, and now I'm going to apply the product rule for this. So we're finding the derivative of the first, which is theta, so 1 times leave the second alone, which is sine theta. Now we leave the first alone, so theta, and then times the derivative of the second, which is cosine theta, giving me a final answer of 3 plus sine theta plus theta cosine theta. Now we're going to apply the product rule again. We have find the slope of the normal line to the graph of the following function at the given x value. To find the slope of the normal line, we first have to find the slope of the tangent line, meaning we're going to have to find g prime of pi. And then once we get that answer, the slope of the normal line would be the opposite reciprocal. Now I put down here in blue. It is important to be aware that questions involving differentiation will not tell you what rule to use. You must know which rule to apply depending on the format of the question. So when I see a question like this, you have to notice, okay, this is a product. I'm going to have to apply the product rule. So let's go ahead and do that. We're going to find g prime of x first before I plug in pi. So the derivative of the first term, which is 2x, and then we leave the second alone, so times sine x, plus x squared times the derivative of sine, which is cosine x. This is my derivative. I can't really do much else from there. So we leave it, and that's fine. Now we're going to go ahead and plug in pi. When we plug in pi, we get 2 pi times sine of pi plus pi squared times cosine pi. Now the sine of pi is 0 plus pi squared, and the cosine of pi is -1. So this is just 0. So we get that g prime of pi is equal to -pi squared. This means that the slope of the normal line would equal to a positive 1 over pi squared. Let's try another question. We have g of t is equal to t squared times cosine t, and we want to find the equation tangent to the graph when t is equal to pi over 6. So remember that we need to find the point of tangency and the slope of tangency, which is the derivative, in order to write the equation of the tangent line. As a reminder, the equation of tangent lines are written as y minus y1 is equal to m times x minus x1, where y1 and x1 represent the coordinate of the point of tangency, and m is obviously your slope. So first, let's find the point. So that means that I'm going to plug in pi over 6 into my function. This will give me my point of tangency. So we have pi over 6 squared times the cosine of pi over 6. When you are squaring a fraction, you're basically applying the exponent to both the numerator and the denominator. So pi over 6 squared is pi squared over 36. And the cosine of pi over 6 is the square root of 3 over 2. Therefore, g of pi over 6 is equal to pi squared, square root of 3, all over 36 times 2, which is 72. So my point of tangency is pi over 6, comma, pi squared square root of 3 over 72. Now, I put here also in blue, not all of our answers are going to look very pretty. This does not look very nice, but it is correct. So let's keep going. So now we're going to find g prime of t. We need the derivative in order to find the slope. This is a product, so I'm going to apply the product rule. The derivative of t squared is 2t, and then we're going to multiply with cosine of t, plus t squared times the derivative of cosine, which is negative sine t. And we can just rewrite this so that it's 2t cosine t. And because of this negative, we're going to make it minus t squared sine t. Now we're ready to go ahead and plug in pi over 6. So g prime of pi over 6 is going to equal to 2 times pi over 6 times the cosine of pi over 6 minus pi over 6 squared times the sine of pi over 6. Let's simplify this a little bit. 2 times pi over 6 is 2 pi over 6, which is pi over 3. The cosine of pi over 6 is square root of 3 over 2. Minus pi over 6 squared, as we already established, is pi squared over 36, times the sine of pi over 6, which is 1/2. Let's simplify this one more time. Over here, we have pi square root of 3 over 6 minus pi over 2 times 72. This is my derivative. I can't combine anymore because first of all, we have pi times the square root of 3 minus pi squared. It's a little complicated. So we can just leave our derivative like that. So this represents our slope. Now we're ready to write the equation. Y minus y1, which is what we found earlier. So the pi squared square root of 3 over 72 is going to equal to my slope. This is all my slope, so I'm going to leave this in parentheses. Pi square root of 3 over 6 minus pi squared over 72 times x minus pi over 6. And that would be the equation of my tangent line. Now we're going to look at how we can apply the product rule using graphs. Here we have graphs f of x and g of x. And it says here that p of x is equal to f times g. And r of x is going to equal to x squared times g. And we're going to use these graphs to answer these questions. So first here it says if g prime of negative 4 is equal to 2, what is the value of p prime of negative 4? So first we need to find the general equation for p prime of x, which we've already established earlier. When you have a product, it would be f prime of x times g of x plus f of x times g prime of x. This is my general equation for the derivative. Now I'm ready to plug in negative 4. So p prime of negative 4 is going to equal to f prime of negative 4 times g of negative 4 plus f of negative 4 times g prime of negative 4. F prime of negative 4. Now I have the graph of my function, not the derivative. However, here is negative 4 on f of x. This is a line. And in order to find f prime, I would need to find the slope of that line. So when I look here, you can choose 2 points on either side, so here, and we can just determine the slope. And when I check it out, I see that the slope of this line, I'm going down 1, right 1, down 1, right 1, etc. the whole time. So that means that the slope is negative 1. So f prime of negative 4 is equal to negative 1. times g of negative 4, that is just the function value, which is 6, plus f of negative 4, which is negative 1 as well. And then g prime of negative 4, if you go to the graph, it's a curve, which can be kind of difficult to determine unless you have a point on either side, which we could figure out, but why? If in the actual question it tells me that g prime of negative 4 is 2, so 2. So negative 1 times 6 is negative 6, and negative 6 minus negative 2, minus 2 would give me negative 8. So p prime of negative 4 is negative 8. Now it says to find the equation tangent to the graph of p of x when x is equal to negative 4. We have p prime of negative 4, so that would be my slope, but I am missing my point of tangency. So that means that I need to find p of negative 4. And remember that p of x is f of x times, f of x times g of x. So that would be f of negative 4 times g of negative 4. F of negative 4, as we already saw, was negative 1, and g of negative 4 was 6. So my point of tangency is negative 4, negative 6. So now I'm ready to write my equation. Y minus negative 6, so plus 6, is equal to my slope, so negative 8, times x minus negative 4, so plus 4. And this would be my equation. Now let's go to the next section here where we're dealing with r. We have r prime of negative 2 is equal to 20. What is the value of g prime of negative 2? So I'm just going to erase this little bit here so that I have some space. Now we're given r prime, so we're trying to figure out what is g prime. So we first need to get the general equation for r prime of x. If this is r, remember this is another product, so we would find the derivative of x squared, which is 2x times g of x, plus x squared times the derivative of g, which is g prime of x. And we're trying to figure out g prime of negative 2. So we're going to make r prime of negative 2 is equal to 2 times negative 2 times g of negative 2 plus negative 2 squared times g prime of negative 2. So I just plugged in the negative 2 everywhere that I saw in x, and now we're going to work this out. So r prime of negative 2, I was told, was equal to 20. So I'm substituting r prime of negative 2 for 20 is equal to 2 times negative 2, which is negative 4. G of negative 2 is negative 3. And then plus negative 2 squared, which is 4, times g prime of negative 2, which I'm trying to solve. So now I'm just going to work this out once more. Right? We have 20 is equal to negative 4 times negative 3 is a positive 12, plus 4g prime of negative 2. Now we subtract the 12. 20 minus 12 is 8, is equal to 4g prime of negative 2. And finally, divide the 4. So g prime of negative 2 is equal to 2. To find the equation of the tangent line to the graph of r of x when x is equal to negative 2, we already know r prime of negative 2, which is 20. This is my slope. So I'm just going to make a note here. But what I need is r of negative 2. I need the point of tangency. So I'm going to plug it into my equation for r, which is x squared times g of x. So negative 2 squared times g of negative 2. Negative 2 squared is 4, and g of negative 2, as we already saw, was negative 3. So we get r of negative 2 is equal to negative 12. That is my point of tangency, negative 2, negative 12. So my equation would be y plus 12 is equal to 20 times x minus negative 2, so plus 2. And this would be my equation for the tangent line at x is equal to negative 2. Now we're going to apply the product rule, but using charts. So every time we learn a new rule, we're going to go through all different representations. We did algebraically, we did using graphs, and now finally we're using charts. So this first particular question says, if q of x is equal to 2f of x minus 4g of x, what is the value of q prime of 4? So first I need to find q prime of x. Now, when you look at q of x, none of these are products. Okay, whenever you have a number that is being multiplied to a function, remember that that's just a constant which tags along with the derivative. You don't have to apply the product rule for this one. So this would just be 2f prime of x minus 4g prime of x. And now we can plug in the 4. So q prime of 4 is going to equal to 2f prime of 4 minus 4g prime of 4. Always make sure that you first plug in the number. Don't just start substituting numbers from the chart, because sometimes if we make a mistake, it's at least easier to see where we made that mistake. And this kind of keeps us organized. So we have 2, now f prime of 4. This is the column for f prime. So you got to make sure that you looking at the correct part of your chart. This is x is 4, so f prime of 4 is 2. Minus 4. Now g prime of 4, here's the column, right? So 4. G prime of 4 is negative 3. 2 times 2 is 4. And negative 4 times negative 3 is a positive 12. And 4 plus 12 is equal to 16. So that's q prime of 4. Now, this next one reads, if p of x is equal to negative 2f of x times g of x, what is the value of p prime of 3? This is a product rule question because we have f of x times g of x. This negative 2 is just attached to that f of x, so you just tag it along. You don't really do anything with that negative 2. So first we're going to find p prime of x. Remember, find the derivative of the first term, which would just be negative 2 f prime of x times g of x plus negative 2, so we're really going to write minus, minus 2, leave the first alone, f of x, and times the derivative of the second. Now we can plug in the 3. P prime of 3 is going to equal to negative 2 f prime of 3 times g of 3 minus 2 f of 3 times g prime of 3. Now we're just going to use the chart to substitute all of these numbers. Negative 2. Now f prime of 3. This is the column, or rather the row for 3. So I'm just going to box it here so I know, because I'm looking at all of those values. So I know that I'm just using those. F prime of 3 is negative 4. G of 3 is negative 3. Minus 2. F of 3 is negative 2. And G prime of 3 is 2. And now we just multiply and combine. Negative 2 times negative 4 is a positive 8, times negative 3 is negative 24. Negative 2 times negative 2 is a positive 4, times 2 is a positive 8. And negative 24 plus 8 is equal to negative 16. So that's P prime of 3. Now we're going to find the equation of the line tangent to the graph of v of x, which equals to x cubed plus times f of x when x is equal to negative 1. So I'm just going to go ahead and erase what I boxed here, since now we're no longer just looking at x is equal to 3. We're using negative 1. And I don't want to confuse myself or you. So in order to find the equation of the tangent line, remember that we need the point of tangency. So first I need v of -1, which would equal to -1 cubed times f of -1. -1 cubed is just 1, and f of -1 is 2. So my point of tangency is -1, my x value, and my y value, which is 1 times 2, is just 2. So now I need to find the derivative so I can get the slope. So we need v prime of x, which would equal to the derivative of the first, so 3x squared, leave the second alone, plus x cubed times the derivative of the second, which is f prime of x. Now I'm ready to plug in -1. So v prime of -1 is going to equal to 3 times -1 squared times f of -1 plus -1 cubed times f prime of -1. -1 squared is a +1 times 3 is just 3. F of -1 is 2. Plus -1 cubed is -1 times f prime of -1, which is 1. So this gives me 6 minus 1, which is equal to 5. This is my slope. So now my equation would be y minus the 2 is equal to 5, my slope, times x minus -1, so plus 1. Last one here. We have k of x is equal to 2f of x plus 3 times 3 minus g of x. And we're just going to find the value of k prime of 3. So first we need the general equation for k prime of x. Now k of x is a product. We have 2f of x plus 3 times 3 minus g of x. You don't have to distribute this. If you do, you can, it doesn't matter. We're just going to go ahead and apply the product rule. So we have 2f of x plus 3, so the derivative of my first factor, which is all of this, would be 2f prime of x times, we leave the second alone, so 3 minus g of x, plus, now we leave the first alone, 2f of x plus 3 times the derivative of the second, which is negative g prime of x. We don't have to worry about distributing anything or anything like that. We can just go ahead and directly plug in 3 and then just worry about our numbers and then work within the parentheses and multiply everything out. So k prime of 3 is going to equal to 2 f prime of 3 times 3 minus g of 3 plus 2 f of 3 plus 3 times negative g prime of 3. And now we're just going to use the chart to substitute all of these numbers. So we have 2 times f prime of 3, which is -4, times 3 minus g of 3, which is -3, so plus 3, plus 2 times f of 3, which is -2, plus 3, times negative g prime of 3, which is 2. Within this parentheses, we have 2 times -4, which is -8, times 3 plus 3, which is 6, plus 2 times -2 is -4, and -4 plus 3 is -1, times -2. -8 times 6 is -48, plus -1 times 2 is a +2, and -48 plus 2 is -46. So that would be my k prime of 3. And that's the product rule.